Okay. In Chapter 13, we're going to be talking about scheduling, which is the third step in our master planning cycle. And it follows the forecasting and capacity and elements that we talked about. And there's different types of scheduling and planning that are involved here that we'll talk about. Remember, keep in mind the type of operations we talked about in earlier chapters, which deal with continuous flow and maximum runs versus job shop and smaller customized type of operations. This is a very important factor in how we schedule. There are concepts that we'll be dealing with in this subject. Shop floor control is one of them. Scheduling operations, another. Production activity control, and detail planning and schedule. All are elements of the scheduling concept. It is one of the, not just the last, but most important constraint in the capacity planning hierarchy, because you can do all the other things, and if you don't have a good scheduling plan and operation, you may still fail. Scheduling focuses on the time phasing of both the production as well as the delivery of the products, and it's more near term. It's more the near term aspect of a master plan, because it deals on the most immediate time frames that you need to complete and deliver your product or your service. The same objectives that companies use in other aspects are involved here, and the same trade-offs are involved. Your trade-offs are the benefits of high efficiency operations vis-a-vis low inventories and good customer service. You're always trying to maximize those elements. One of the things we consider in this chapter is what we call batch scheduling. And that means you're not running your operations in a continuous flow type of method, but you have starts and stops. And what you do is you run things through in batches, either because you want to control it in smaller units, or because of your time frame, or you need to set up and tear down in between. There's a variety of reasons. What it does is make the scheduling environment more complex, has a lot of what we call queue times figured in there because of the start and stop. And you do have a lot of waiting time in the process for work waiting to be moved to the next stage or station. Just a rule of thumb, you will probably experience it up to, and maybe even more, 20% in that range of efficiency loss in throughput versus a continuous run type of operation. But in like many cases, which we'll talk about in a later chapter, material requirements planning is a concept that you incorporate regardless. Difficulties in scheduling are caused by many factors. One is the variety of the jobs that are being processed. Could be a very customized operation where no two jobs are the same, which means that there may be a difference in the routing and the processing of each job that you have. You may have different orders that are running through the operation at the same time, and that adds to the complexity of your operation. And you may have issues with common resources, especially when you're running simultaneously different jobs, because everybody's trying to compete for the same resources. and by that we mean people and machines. The production control department has several responsibilities in this operation. They have to load the machines, check the availability of material, make sure the labor is available to run. They have to sequence the operations to make sure that the work orders are where they need to be and the sequence of work is done according to plan. And then they have to monitor the operation to make sure everything's going right. One of the ways that you will probably, a tool that you use to help do your job in this area is a Gantt chart. And we'll talk about Gantt charts in a following chapter when we talk about project management as well. The key thing you want to focus on here is machine performance, total time to complete a particular job is an important element, the machine utilization, which is we talked about in the capacity chapter, the percent of time a machine is used. This is one of the most critical factors in determining what costs are involved, because the more downtime you have, the more time you have on a machine that's not used to produce, it's going to increase your costs. And you use Gantt charts to monitor the progress of the jobs and to help implement your production plan. A very important topic in this subject in this area is the subject of bottlenecks. This comes back to something I mentioned in one of our earlier chapters when I referred to Elijah Goldratt and the theory of constraints. Goldratt deals with the concept of bottlenecks in flow charts and how to deal with them, how to analyze them, and how to solve them. Bottlenecks are things that we deal with almost on an everyday basis. When you get on the freeway to go to work, 4 out of 5 days you're going to be running into bottlenecks and trying to navigate around that. Likewise, in a lot of different flow operations, there's quite a few bottlenecks that get involved that back things up. Construction, almost every type of process you can think of runs into bottlenecks. The key thing you want to do is determine how to solve it, and you use some of the tools such as Gantt charting and others to help get a visual analysis of where your problems are. Finite capacity scheduling loads jobs into workstations to try to optimize the utilization of both machines and people. It's usually done at a detail level. We call the scheduling, detail planning scheduling, a DPS level, and it's really down to the hands-on part of the operation that we referred to earlier, that says you've got to really optimize this part of it if you're going to realize cost efficiencies especially. Finite capacity scheduling, on the other hand, is used to identify a lot of things. It helps you deal with the bottleneck concept a lot more and look at the constraints in your total operation and try to determine how to work around it. A finite capacity basically deals with the concept that this is the most you can do. You can't push any more through than what you're capable of handling in a total capacity sense. The theory of constraints that I just alluded to, Goldratt wrote an excellent book, even though it was a fiction book, called The Goal, but it was so realistic, most of us, as we read it, we thought it really was based on fact. The ultimate goal is to be totally productive and efficient in order to make the most money. But according to Goldratt's theory of constraints, you look at throughputs, you look at inventory, and you consider operating expenses as part of the elements in your goal. And you don't count production while it's in process until it's finished and sold. Otherwise, you get caught up with all the work in process that just becomes the bottleneck that we're talking about. The bottleneck determines your capacity. It's a big factor in there, and is used to determine how to increase capacity or throughput. You have to schedule your operations with bottlenecks in mind. A work in process queue is an important thing that needs to be addressed when somebody's scheduling, especially looking at potential bottleneck situations. And on the other hand, you try to make sure that you're not sitting there with too much idle resources. And in ways of reducing the bottleneck, one way is to increase capacity. It's a very expensive way to do that. Another way is to direct works to other parts of the operation that don't deal with or have bottleneck situations. In many cases, a good quality assurance program can avoid bottlenecks by catching rejects before they get to that point. And sometimes you look at the bottleneck area itself and try to determine how to expand it or to avoid some of the problems that cause it. Dispatching, another concept in scheduling, and there's generally a set of rules that a good dispatcher has to have to make sure that the planning of the operation as well as the deliveries are done efficiently as possible. There are different concepts that are used to implement this. One is first come, first served, which means that you prioritize things by the aging of the date. Another way of looking at things is batching them together in like type of operations so you can get some efficiencies that way. Or a third way is to prioritize your work in terms of customer or some other type of measurement and give the important things the top priority in your operation. Dispatching rules get applied in a lot of different situations. They apply both in service applications as well as manufacturing. Different types of measuring sticks that get used in those situations. So in this chapter, we're going to look at a few of those, and you should try to understand that. Planning and control system focuses on the balance of delivery, capacity, and tries to get to answering questions like start and completion dates and control measures to ensure that the job's completed on time. And it's a monitoring and a planning technique.